Welcome! In this presentation we will discuss what happens to the forces acting on the vehicle when driving on an uphill or downhill road gradient. We will also interpret the effects the road gradient has on the running resistance diagram. The mass of the vehicle gives rise to a large force which equals the mass times the gravitational acceleration g. This force acts from the center of gravity towards the Earth's center. On a flat road it is perpendicular to the road and therefore has no component in the longitudinal direction of the vehicle. But this will change when we are driving uphill or downhill, as we shall see. The steepness of a road most of the time is described as its gradient. The gradient is a dimensionless number equal to altitude change divided by the corresponding horizontal movement. In our calculations, we also often need to express the road steepness as the inclination angle alpha between the horizontal plane and the road surface. From the right triangle, we can see that the gradient equals the tangent of alpha. Gradient is most of the time given in percent, and both gradient and alpha are negative when driving downhill. If the vehicle is on an uphill gradient with angle alpha, the mass force is no longer perpendicular to the road. Therefore, it now has a force component in the longitudinal direction of the vehicle, which we call gradient force. Trigonometry helps us calculate the size of the gradient force since the forces are parts of a right triangle. Alpha is the angle between the mass force and the normal force of the road. Therefore, the gradient force can be determined with this equation. It equals mass of vehicle times g times sine alpha. This diagram shows the running resistance on a flat road. Since the gradient force is independent of vehicle speed, it will only add a constant to the running resistance force for a flat road. Therefore, an uphill gradient will only shift the running resistance force upwards in the diagram. So, the total running resistance force equals aerodynamic resistance plus rolling resistance plus gradient force. Notice that already at a modest gradient like 5%, the gradient force is bigger than the sum of rolling resistance plus aerodynamic resistance, up to about 130 km per hour for this vehicle. If the vehicle instead is driven downhill, the conditions are the same, except that the angle alpha becomes negative. That changes the direction of the gradient force, so it now acts in the forward direction. The geometry looks similar as for the uphill situation. Therefore, we can use the same equation as before to calculate the size of the gradient force. This equation will also automatically give a negative sign of the gradient force when entering a negative road angle. So, a positive gradient force shall be interpreted as acting in the reverse direction of the vehicle, while a negative force acts in the forward direction. A downhill gradient will shift the running resistance force downwards in the diagram. Notice that the y-scale has changed to include negative force. Again, the total running resistance force equals aerodynamic resistance plus rolling resistance plus gradient force, which is now negative. The resulting running resistance force is the black curve. For the downhill gradient, the total running resistance force is negative up to a speed of 130 km per hour. This is caused by the gradient force being negative and bigger than the rolling resistance force plus aerodynamic resistance up to 130 km per hour. The result is that theoretically this vehicle on a very long 5% downhill gradient would be able to reach 130 km per hour without any traction force from a powertrain. It could be driven only by the gradient force. However, it would take a very long time to reach that speed, only accelerated by the gradient force. Summary: in this video you have learned how the mass of the vehicle gives rise to a gradient force in the longitudinal direction of the vehicle when driving uphill or downhill. The value of the gradient force can be calculated as vehicle mass times g times sine alpha. This force changes with road gradient but is independent on speed. Therefore, its effect on the running resistance force is a parallel shift upwards for uphill gradients and downwards for downhill gradients. If the downhill gradient is significant, the running resistance becomes negative and will act to accelerate the vehicle. Thank you for watching.